Well, thank you for the opportunity to come and talk to you guys today. I know we've covered a lot of information so far, and I'm going to maybe address some of the questions that came up, particularly around what we are doing for fleet management and how we're looking at making it easier to not only have that visibility and enhanced SRE model that Derek went into detail about, but also as a manager of many clusters, what can I do to make the delivery of common policy, the delivery of applications, getting visibility into what's running and deployed in those clusters more available. I'm going to show just a couple of slides, and then we're going to jump into a demo, and we'll take questions. Feel free to interrupt me as we go. So first, maybe the first thing I'll talk about is what actually drives growth in terms of clusters, right? I think we've seen this pattern now in the industry many, many times. We had virtual machines and sort of VM sprawl. We saw containers and container sprawl. And now, as Derek's highlighted, the ability of platforms like OpenShift and even managed Kubernetes services to be created through an API and created on demand makes it much easier now that we're going to see this next generation of cluster sprawl. So first, we typically see small dev teams that have multiple clusters for purposes like development, QA, production. They still want to maintain consistency across those clusters. And many consumers of Kubernetes, maybe when they're first getting started, they're treating them maybe like they used to treat VMs, right? They might have used to have SSH'd into VMs and run a set of manual scripts, or they had some things partially scripted, and maybe they're doing the same thing with those clusters. So that's something that ultimately begins to become a problem in terms of the ongoing cost and maintenance. When we begin to look at organizations that have started to adopt Kubernetes for a portion of their applications, we begin to see maybe more regional clusters deployed in different areas that they're trying to manage. They're beginning to deploy a percentage of their total workloads on Kubernetes, and they're dealing with how to keep all of those different localities of clusters in a consistent form and understand what's going on within them. And then we grow that all the way out to edge, where we'll see, and I think I saw the comment on Twitter, right? You're not hip if you don't have 5G in a slide. That's very true. And Kubernetes and that powerful container orchestration layer likely will become a key driver to enable telco-style workloads as we go forward. So how do we make it easier to manage those environments as well? We think about the journey, we might sort of group it into three major use cases and to some extent perspectives on those different scale problems. When I'm in the single cluster mode, I'm probably still thinking about the developer's concerns. How do I create clusters more easily? How do I manage ongoing drift? And then how do I actually promote applications from a development environment all the way out to a full production environment? When we get into that medium, intermediate cluster growth, we tend to see more of a DevOps capability. So creating clusters, maybe not through a self-service console, but as part of a GitOps-driven style method or some other service catalog-driven method, where I create some clusters that I manage and babysit over long periods of time. Those typically are more production environments. I care more about in-place upgrade and making sure that's stable. And then in earlier phases of the developer lifecycle, I might create clusters in a CI/CD job, deploy components, do validation, and destroy that cluster. So the transient state or nature of clusters probably becomes more and more stable as you get closer to production. But we see, still the same problem of, just like dev, QA, prod, sort of three distinct stages, how do I maintain that cluster that's spun up only for a 30-minute CI/CD job has a consistent look and feel, a consistent set of policies that I also run in production so that my application gets a realistic test platform for validation. And then what Derek highlighted is the power of this open hybrid cloud platform that runs consistently across all of the major cloud providers, that Red Hat is very focused on how to provide the best reliability and customer experience with connected information, connected details about whether clusters are healthy. And what we wanted to do is also to begin to bring, just like we have a SaaS capability with what you saw with OpenShift Cluster Manager, what I'm going to focus on is where we're bringing some of those capabilities in a software form. And that's something that I'll mention in just a minute as a new offering. And that software capability uses some of the same technology. Under the covers, we're using the same Hive componentry that's used in the SaaS. but we're looking at the use case now of wanting to manipulate what's in those clusters more actively, sort of a universal remote control for all of my OpenShift and Kubernetes clusters across all cloud environments. And that's something that we'll dive into and see live in the demo. So yesterday, as part of our Red Hat Summit, we announced the tech preview availability of Red Hat Advanced Cluster Management for Kubernetes. This capability looks at 3 primary use cases, and I'm going to dive into each of these in the flow. But here's what I want you to take away as high-level points. In the first one, we're really looking at the lifecycle of the cluster itself. How do I create clusters in a consistent and predictable way, regardless of where they're running? In some cases, there was a question earlier about some of the VMware-based, maybe vCloud Director or other APIs, and there are going to be other platforms that we may not dynamically provision a cluster. For any OpenShift cluster, I can always import it, even if I can't create it directly from this interface, and still manage it for all other use cases. So we still have that powerful capability, even if our provisioning engine or list of tiles doesn't show your type of environment today. If you've got an OpenShift cluster running, you can always import it and bring it under management, even if we didn't create it. The other aspect of cluster lifecycle management is that upgrade process. Derek showed you what it looks like to run it for a single cluster. What I'll highlight is how we can actually scale that out to a fleet and trigger upgrade across many clusters. Within cluster management, we also think about visibility. If we scroll back maybe 10 years, things like configuration management databases were a way of trying to understand what was actually running in a data center. And it required a lot of work to keep those models up to date, to understand whether they were current. So with Kubernetes, because everything is very API driven, things like understanding what's running on that cluster become an API call, as opposed to a static database that's sort of running longer term. But as soon as I begin to branch out to where now I have more than one cluster, Kubernetes itself, I can say, show me all deployments on one cluster. What we're going to enable and show you is ask me for all deployments across all clusters. So providing that deeper visibility to understand anything that I can query from Kube API, I can run a search across all of my clusters, again, regardless of what cloud they're running on or what infrastructure they're running on. And if I have the correct role-based access permission to view that result, I'll get to see that information. I'm going to focus on cluster lifecycle first. We'll look at creation flows, and we'll look at visibility flows. The second domain I'm going to look at is policy-driven, what we'll call governance, risk, and compliance, or GRC. If you're not focused on the Chief Information Security Officer or CISO type of role, GRC might be a new term. But all it really means is that we're defining what are the set of technical controls and policies that allow us to validate we meet all of our regulatory or data security standards compliance designs, right? As a CISO, I might say, here are all the things that have to be controlled. And what we're enabling with ACM is being able to represent those as policies that can be either audited, so I can understand whether a cluster is compliant with my policies, or actively enforced, so that I don't have to always ask. I'm not just collecting evidence, I'm actually enforcing that change on an ongoing basis. So you couple that with our operator-driven approach to managing behavior within a cluster, now I can do some really powerful things. I can create a policy that actually drives configuration of my identity providers for every cluster according to whatever my corporate standard is. I might create a policy that drives the deployment of a security operator that looks for image vulnerabilities across every cluster. And I'll show you those examples here in just a minute. And then finally, I'm going to take a step back from maybe the role of what an SRE who's managing the clusters is concerned about, and sort of blend to either an app SRE role or even a developer who wants to define an application, right? So we created a container, we bound it into a Kubernetes deployment, we've run it on one cluster. Now I might want to assimilate this one deployment with other deployments or other services or other stateful sets. And because of various reasons, I might want to either spread them across different regions for availability, or I want to distribute different parts of them to different clusters because some clusters are optimized for higher performance storage than others, right? And I've got a cost metric that I'm optimizing so that only really the workloads that need that high performance capacity or high performance storage are on that cluster, and any other workload that's just an API that's stateless can run on cheaper hardware. And so with our application lifecycle components, we're looking at the same type of dynamic placement that I'll show you with policies. We can also do with applications, and we can distribute those components everywhere. And then again, tie into search to go and see where are they actually running and are they healthy. Let me show you one other picture, just so the mental model is accurate. What Derek showed with OpenShift Cluster Manager was a SaaS capability. It's a SaaS portal. Every OpenShift cluster that I spin up, I can choose to connect back in order that Red Hat can help me if there is a software problem in that cluster. What I'm going to show you is a software component that is also deployed as an operator on OpenShift. And we have a component called a hub. And the hub is what, as the admin or the users I'm going to interact with mostly, it's sort of the primary interface. And then I've got several managed clusters as well. And on each of those managed clusters, I've deployed some pods that tie back into ACM and provide me with search indexing, application lifecycle management, policy lifecycle management, etc. I can deploy the hub operator on any OpenShift cluster that is 4.3, 4.4, or above. And that means I could run it on an OpenShift that's running as a managed OpenShift in a cloud provider, or on my VMware or bare metal stack in my data center. So a lot of power and flexibility. And again, this speaks to kind of the goal of the hybrid model.
Michael, I have a question.
Yes, sir.
About the architecture. The hub cluster that you're calling it, is that something that needs or would be recommended to run separate from all your other applications? Would you want like a dedicated cluster just for this advanced cluster management? Or would it run alongside some of your other production applications?
I think in general, we almost always recommend that you're going to have a separate cluster that is dedicated for this purpose. And there's different reasons for that. One might have to do with access control, right? Who do I want to be able to log into that hub cluster? Who's available to that identity provider? And then capacity management. Under the covers, what we need to run the hub today is very marginal. So on the order of 8 CPU and maybe 16 gig of memory in the current tech preview. And so your cluster might be 6 nodes, or even maybe smaller than that, but probably 6, because you're going to have a master and 3 availability zones and a worker and 3 availability zones, right? And then you're going to deploy the hub into that environment. And so it's not necessarily big from a capacity. It's not that we need that extra capacity, but the lifecycle of the hub is going to be the longest lived cluster across all of your other clusters, more likely than not. And for that reason, having it as its own dedicated cluster typically makes sense.
Right. So that life cycle that you're talking about, how do you guard against failure and corruption for that hub cluster? And what's the upgrade process for it? If my hub cluster is down, do I lose all management capabilities? If I want to recover it, is it as simple as just restoring a database, or is there a lot more to it than that?
Great question. So if we dig into the architecture a little bit more, there are a set of API components that ultimately are managed as etcd. And we're making some changes between the tech preview and our general availability to where all of those resources will be managed as part of the etcd that is the Kubernetes OpenShift backbone, right? So your standard DR procedure for that OpenShift cluster will be sufficient to guard against losing data from the hub, right? So it's not going to be an extra layer of procedure from that perspective. We can still trigger an upgrade on OpenShift itself. And so bring the version of Kubernetes with all fixes up to date. And because we spread the pods for the hub across different availability zones, the OpenShift upgrade procedure works node by node, right? It'll do one master node, get it into a healthy state, go to the second one, and so long as 2 master nodes remain available, etcd maintains quorum, the control plane remains healthy, you're good to go. For our workloads that are running on those worker nodes, for the ACM pods, same pattern. 1 worker node goes down, is taken out of the pool, is upgraded. We update the Kubernetes layer, we update the operating system, maintain, bring it back to health, add it back to the pool. And so in that window of time, instead of having 3 replicas for an API service that's used by ACM, we'd have 2. And when the new pod comes back, when the new worker node comes in and we can schedule that 3rd pod, it'll come back up. So we can actually still drive the upgrade lifecycle of OpenShift underneath ACM, just like we would any cluster. There's no magic there. And because our primary data is actually going to be in the same data stores as OpenShift, you'd have the same disaster recovery procedure if you were to lose 2 or more master nodes at the same time. So one of the key things to take away from this picture is really simply that I've got OpenShift running across many different clouds. I'm looking at my ACM hub, and in this dashboard, I can see the various clusters that have connected, and I can see in what cloud they're connecting from. We're even demonstrating here that if you do have a managed Kubernetes provider, we can still do things like manage policy and applications to that GKE or EKS or AKS provider, just like I could if it were OpenShift dedicated, Azure OpenShift, or IBM's managed OpenShift service. So anything related to sort of the query, search capability, policy management, et cetera, we can do on those managed kube clusters. The cluster lifecycle behavior is something that is unique to the management of OpenShift specific clusters. So if I take a little bit of a view, how many clusters do I have in this environment? I can see, I'm looking at, let me move my video window here. I'm looking at just over a dozen clusters that are under management in this example. And whereas Derek showed what it looks like to upgrade a single cluster, what you'll see is that I represent every cluster, its current version, and whether an upgrade is available. And just like Derek showed for a single cluster, I could trigger that for 1 cluster. But the power and the goal of this type of fleet management is that I could trigger multiple, and I'll pick the same base version here. I could trigger the upgrade of multiple clusters at the same time. So this is now where ACM brings more of that universal remote control for all of your OpenShift clusters that have been deployed and managed.
Hey, Michael.
Yes.
Real quick. Did I hear you say that you can manage out of this Kubernetes clusters that are not on OpenShift, or did I not hear that?
So you heard correctly. So here I've got some that are EKS and GKE.
Okay. And that's that's what's visualized there is the district that it's showing. If it was an OpenShift cluster, it would show OpenShift, obviously.
Correct. And I just don't happen to have an Azure OpenShift or an IBM OpenShift.
Okay. No, that's fair. I just wanted to make sure. I thought I heard that, but I wanted to make sure that I did actually hear that.
It's a great question. And just to highlight what we would do to bring that cluster in, I basically walk through an import command. I give it a name and a namespace. And when I click generate command, I get a command line that I go and run against that remote cluster. So it's every cluster that responds to Kube API, I could run that command against, and that's what will deploy the agents and the pods that then connect back to here.
So you're just applying manifest in that existing cluster, and then it's attaching back to the management plane.
You got it.
Okay.
So maybe let's take a look at what it looks like to create a cluster from this interface. So here we'll name this, I'll put this one in GCP. And I'll call it Durham. And we'll give it a domain name. Now, the domain name is the one thing that needs to be available ahead of time. So in my Google Cloud DNS, I've got a base domain name. And when this OpenShift cluster is provisioned, it'll create wildcard entries that are needed underneath my DNS capability. And again, let me move my video so it gets out of the way of my screen. You guys may not see that. I'll pick my distribution. I'll pick my target cloud provider. Here you can also see we have a bare metal provisioning capability. That's going to be officially tech preview in our first GA. And it's something we're working with customers to continue to validate because there's lots of little things there, but it becomes a really powerful way of provisioning OpenShift against your own bare metal environment. Now, I'm going to pick a certain version of OpenShift. I'll go ahead and pick RC4. And I have predefined my cloud connection credentials, and I'll select those here. Now, what Derek showed in the slide that highlighted what the OpenShift Cluster Manager is doing, you saw concepts like Hive and machine pool, cluster deployment, and I can see those same concepts represented here in the UI, and I can manage and manipulate these, so I can change the size of a worker node that I'm going to provision against that cloud provider. If my cloud provider was Amazon and I did the dropdown, I'd see the Amazon types. I can choose how many nodes I want in this pool. I can add multiple pools, and I can decide what labels I want assigned to that AWS EC2 VM or that GCP VM, along with all the other things that will be created, right? Because OpenShift.
I have a question.
Yes, sir.
Michael, this has been really interesting, but at some point, whether during your presentation or later, I'm coming from the VMware world where I'm used to dealing with VMs, storage, memory, compute, etc., and feeding that to the applications. I'm not a Kubernetes guy, so I'm not getting the connection between this and the people that I serve. Ultimately, people asking for application resources.
Okay, so let's play that out. So today, you might give someone a virtual machine in VMware, right? You get a service request ticket in. I need this much capacity. I need 1 or 3 or 5 VMs of this size. When I manipulate these settings that you're seeing here, and I'll drop into the YAML just for a minute, just to kind of show you what it's creating. What it's actually doing is it's updating a configuration YAML file that's providing size details for the platform that I'm targeting. If I had, and it's not in this UI, but underneath this install config, if I go to the OpenShift installer, I can input data about my VMware hosts that I'm going to assemble into a cluster. So instead of GCP as the platform and a Google Cloud provider type, I'm going to have a VMware provider as the platform with the details for those hosts. What's different between our support for an API-driven creation of OpenShift, like you're seeing here in VMware, is that today we typically have teams like yourself that have a certain process for how you create VMs. And we've dealt with lots of clients that don't want to open up the APIs between the teams that manage the virtualization resource and the teams that consume them, like the app teams or other workload teams. And so what we do with an OpenShift today is we allow you to create the VMs. So you might provision 6 virtual machines. And then I would describe those virtual machines in this type of install config and run that OpenShift installer. And at that point, it's going to take the VMs and it's going to create the resources on them in order to assemble the Kubernetes control plane and in order to create a worker pool of nodes within Kubernetes.
So that's pretty straightforward. I love that explanation. Thank you. Next, part 2 of that question: how's this different from vSphere 7? I mean, if I'm writing the check, if I'm the infrastructure guy and I have to write the check for vSphere 7, and I have to debate whether or not to put OpenShift on top of that check, what additional value am I getting? Okay,
great question. So let's dive into this a little bit here. If you look at the vSphere capability and the OpenShift capability, the thing that all users benefit from, regardless of which side of the line you fall on as your preference, is that we've all agreed Kubernetes is the answer. Right? We've all agreed that Kubernetes is that strategic direction for managing workloads in a cloud, and particularly in a hybrid cloud environment. The next level is between those two products and capabilities, one company has been focused in the upstream for more than 5 years, working to really enable Kubernetes to be enterprise grade. One company has a very strong dedication to open source, and it's part of the DNA all the way back to when that company was started. And every aspect that we have within OpenShift is open source. Some of this technology that I'm showing you today originated within IBM, and we've moved it into Red Hat, and we're open sourcing it as we go. But all of this will ultimately be open source for anything that doesn't happen to be there today, because that's part of the core DNA of Red Hat. And when you look at that notion of what runs on a particular set of infrastructure, one of those two vendors has a common distribution of Kubernetes that you have seen today run on virtually every cloud configuration that you could imagine, managed, self-managed, on different cloud providers, etc. And one of those vendors has multiple distributions of Kubernetes that they're trying to normalize into which version gets run on vSphere, which version gets run on public cloud partners, etc. So when you look at strategically, the differences that I highlight are the scope and contribution level of Red Hat in the community, the commitment to a purely open source solution, and the focus on the exact distribution that's been well established in the industry, running consistently across that open hybrid cloud. Those are the things that I would highlight as sort of the core differences. When you look at the idea of having a Kubernetes API provision a resource, there's some similarity there. But when you look at the underlying API and the implementation, you're dealing now with the difference between a proprietary closed source implementation that uses some upstream versus a completely open API and implementation from top to bottom. So hopefully that addressed the question there. Let's push forward. I know we had originally scheduled to close at 12. We'll try to keep it to that window, but maybe I'll look for guidance from the organizers. If I can go a few minutes over that, just let me know. So what I wanted to hit here is that notion of creating clusters, of being able to import clusters regardless of where they're running. The next step we typically see is, again, that kind of traditional CMDB problem. What's running across all of those clusters? Kubernetes API can tell me what's running on one cluster. Here I've got over 2,300 workloads spread across my dozen plus clusters. And I can summarize all of that with one search query, which you saw comes back extremely quickly. So I've got over 775 running deployments. I can see the clusters they're on. So here I have some deployments running on a cluster named India, some that are running on the local cluster, and I can see objects that are related to them. So I can see what, maybe in this case, I want to see the persistent volumes that are related to a set of my workloads. And this now becomes a really powerful way of understanding what's out there. If I'm a developer, I might want to be able to see the pods that are associated with my application. I'll show you that in a minute. If I'm an SRE that's trying to diagnose a problem, I might look at where is there similarity. And this query language is very simple. We're really looking at sort of key value pairs, search for all kind of API service across all environments, and I can kind of quickly get that result back and kind of go from there. So search and index becomes a really powerful capability to give me an understanding of what's going on in my environment. Another aspect that I won't dive into too deeply, but I do want to sort of present it at a high level, is how, as a Kubernetes or an OpenShift engineer, we typically might see them more in the CLI. And so we do provide a capability that not only can I run commands for Kubernetes, and what we're doing here in our visual web terminal is providing not just the CLI commands, but more of a rich text view that lets me drill into this information in a more seamless way that sort of blurs the line between full web console and hardcore CLI. And that same search capability that I showed you in the UI, I can drive here as well. So now this becomes a really powerful way of digging into a problem and kind of pulling that thread or that string regardless of where it leads me. And so this is another aspect of that visibility solution for clusters. So cluster lifecycle lets me create or import. From there, we looked at kind of search and how I might interact with that information model, which I think becomes more and more challenging over time. Now let's talk about how I drive consistent behavior across all of these different environments. And that's really where our policy framework comes into play. So here I've got a set of policies defined. Under the covers, every one of these policies is an object represented in YAML, and these are Kubernetes API objects. I can store these in source control, and in fact, depending on whether you want to take a look at it offline, the examples that are in our public repo are actually delivered directly out of GitHub. So every time I stand up a new environment, I go and apply this subscription with a simple command, and all of the actual policies get delivered to my hub. And then from here, we're using a very powerful placement engine that lets me dynamically select from all of the clusters that I have under management, where do I want this policy to be applied? And the expressions are very simple. I can match based on a set of expressions where I'm using some basic binary operators. I can match on a set of labels as well. So if you like to use tags to manage, say, the purpose, development, purpose, production, project, insert project code, region, insert region. If you like to use tags to kind of organize all the parts, this becomes a really straightforward way of using those tags and then describing, here are the policies that need to be applied if a particular cluster has a particular set of conditions or tags. And as you can see, it's matched against my New York and my San Francisco clusters. Now, this example, maybe when Derek went through it, he looked at the cluster version operators. One of those dealt with OAuth and identity management. This policy ensures that any cluster that's matched has the same OAuth provider and has a default HT password identity provider that is configured. In a typical enterprise, you're going to configure the LDAP identity provider, and every cluster, regardless of whether it lives for 30 minutes in a CI/CD job or in a production context for months and months or years, ultimately, this will ensure that they all meet the same identity provider in a consistent way. Because as soon as the cluster comes under management, we match it against policies that should be applied, and we deliver those policies down. Now, Keith asked a different question, or maybe it was Ned asked the question about what happens if they're disconnected, if the hub is unavailable. Ned asked this question earlier on DR. And if the agent can't connect home, which we're going to see patterns where Kubernetes is deployed on a cruise ship, and it doesn't have network connectivity to a hub for months. These policies are continuously enforced. So if the cluster begins to drift, the policy will bring it back into compliance always if we're driving enforcement. Other types of policies might deal with security on the operator itself, security of the cluster and images that are on it. And so one other example that's taking advantage of a container security operator is actually ensuring that every cluster that matches, in this case I'm just targeting one, has this container security operator deployed and running, and then validates whether there are any image manifest vulnerabilities identified by that operator. So this pattern is very simple, but very powerful. Automatically, every cluster, because of this policy, whenever it comes under management, will automatically get scanned to ensure that the images on it are not vulnerable. And if they are, I'll get flagged accordingly. Other policies here are simply auditing behavior. So you'll see the example of an inform on a role. So in this case, I have a role defined that my chief information security officer said this is what the developer role should be able to do. I've represented that in an ACM policy. This is what an operator role should be able to do. I've represented that as a policy. I've matched it to a set of clusters. And I can see the clusters that are under violation very easily from this UI. And in this case, I have a couple of clusters. These actually happen to be clusters which are not OpenShift, that don't follow my default RBAC behavior in OpenShift. And I want to know if I import a cluster that doesn't meet all the same security considerations that OpenShift brings out of the box, I want to know what's going on in that cluster. And so here I'm seeing this audit or inform behavior that's giving me that information right away. And I can always slice this up in different ways. Here I'm looking at it based on the data standard. I might look at it based on categories. This is not going to be as relevant if you're just a developer. A developer is just going to know, is it in compliance or not? Thumbs up, thumbs down, am I red or green? But a CISO, whose daily job or organization's daily job is collecting evidence for regulatory audits, now this helps simplify a lot of what they would have to do in order to understand, am I meeting all the technical controls that are expected? And of course, creating, go ahead.
Very quickly. So I see some overlap between this product and the previous one from Derek. And then, of course, this one does much more and different things. Do you plan in the future to merge the two? I mean, multi-cloud, multi-cluster management is becoming a feature more than a product. I mean, everybody has something like that. Now, VMware and Rancher and maybe 2-3 others more. And, you know, so the only difference, I mean, the only main difference between the two now is that one is on premises and the other one is a SaaS product, but why don't you put this as a SaaS product? And you
Great question. Great question. Let me talk about that. I guess the most direct answer for me is that some clients don't want the level of control that we are showing with ACM to be something that lives outside of their data center and their immediate control. So there's a balance there of understanding. Today, a lot of what's in cluster, OpenShift cluster management in the SaaS portal is providing visibility, and customers have exported data out of the data center for years and years, right? Whether it's health monitoring data with like a New Relic or Datadog or whomever, whether it's understanding maybe other metrics that are sent out of the data center. Customers have sent data out of the data center for a long time. But I don't think we've seen really a lot of great examples where, as an industry, customers and the industry as a whole have been comfortable to have something outside of the data center actively control and manipulate hosts in the data center, create clusters, provision applications, et cetera. And so we're trying to find that line. Now, definitely, there's already shared technology between the software and the SaaS capability. We're using the same underlying layer for cluster lifecycle management. I'm not going to show monitoring here because it's something that's a pending feature, but the same Thanos infrastructure that you saw in the SaaS will be available here as well. And at some point, we will offer, more likely than not, this as a managed service on top of that OCM as well. But I think what we're trying to do is to find that balance of how not only hybrid cloud infrastructure presence is adopted through the industry, but hybrid cloud control is actually adopted through the industry, and where some customers want to keep, that are comfortable with visibility outside of their domain, but they want to keep control within their domain. And I can always deploy this in the public cloud and still do that as my choice, but because it's just another operator on top of the OpenShift ecosystem, we're giving users that choice. So let me show the last part, and then we'll wrap up, just around application delivery. With applications, if I just have a single Kubernetes application, then it's not that big a deal to do an apply command and to deliver it into a cluster. When I start to have applications that are made up of multiple parts, and I want to start distributing those across different clusters, then I typically, right, state of the art today, I'd start scripting that out maybe in an Ansible playbook or a bash script. I'd build up a bunch of a framework, and it might be very rigid because it's targeting specifically cluster by name in region 1, cluster by name in region 2, et cetera. And if something happens and one of those clusters goes away, that automation that could push parts of the app out wasn't dynamically watching to see if clusters are healthy or not. It wasn't trying to pivot and move application components if it really had to. So that same dynamic placement behavior is being used here to select a set of clusters to deliver. In this case, we've got the standard Kubernetes guestbook app with a Redis master and a front end and a Redis slave. And it's matched against these clusters. I can see India, Lima, Sierra, Tango. And those components have been deployed on those target environments. If I want to actually use search now in this context, I can actually find where are the pods that are running and are they healthy? And so I clicked on related pods for this app, and I can see, well, in this case, some of these pods are unhealthy. And so now if I'm debugging this problem, if I'm an SRE role, I can use this to dive in further. I can even dive in and at least at a high level begin to view log information to understand where do I need to drill into with more detail. So this becomes a simple way that we get delivery of application components. The applications themselves may ultimately be, and all of the resources that you see will typically be managed in GitHub. In fact, this app is again going back to a GitHub repo. And one of our ACM subscriptions is actually deploying this app from GitHub to the hub. And then when the hub cluster sees a managed cluster that is joined that matches the placement rule, the hub is deciding, well, these components need to run on this managed cluster or that managed cluster. If one of those managed clusters dies and it's got a certain replica count that it needs to maintain, it'll then continue to deliver it. It'll find a new cluster to replace that unhealthy cluster that was taken offline for some reason. So really what I want you to take away, right, are those three core use cases around cluster lifecycle management, this create behavior, being able to drive provisioning to a target cloud, being able to import existing clusters, being able to drive upgrade, destroy lifecycle behavior. I showed you search, right? The ability to dive in and query against all of the clusters in one go and see what's going on. I briefly showed you our visual web terminal, which if you're a Power CLI person, but like the formatting of a rich web interactive web UI, this is really that blend. And under the covers, it's actually built on the same technology as Slack. So it has that sort of long stream of here's all the things I've already looked at. So I can kind of scroll back up and look at the history as well. I looked and showed you some examples of policy-based governance and highlighted examples for how we can configure identity providers on those managed clusters, how we can use some of the OpenShift ecosystem around security operators, container security operator to understand image vulnerabilities, how we can use it to ensure our standard roles are in effect across all clusters that are under governance. And then I showed you at the end a little bit of the application lifecycle management, the fact that we can dynamically distribute components to different clusters, and that the dynamic placement engine will react if those clusters change. If I introduce new clusters that match the command, match the placement rule, or if I take some of them away. And so,
hey Michael,
yes.
Real quick, just for clarification, one more time. When you were talking about the unhealthy clusters, did you actually say that it'll actually self-heal? That if there's an unhealthy cluster, it'll spin up a new cluster and move workloads or pods and services? Or am I imagining that that's what you said?
The only thing that is not consistent is it will not dynamically create a new cluster today.
Okay.
But if you had, let's say I've got a placement rule, let's look at an example here. I've got one placement rule for this app called dev clusters. And this placement rule today will match any cluster with purpose label. And there is a set of decisions that are recorded around it. Okay?
Now, could I create a decision that says if I see this scenario, spin up a new cluster and do the thing? Or is that like crazy thought?
It's not necessarily crazy, but in general, we typically avoid provisioning. If I want to create an autoscaler for my OpenShift nodes, and I make that decision, I can deliver that through a policy so that we will add new nodes based on current demand of the cluster. But I don't think we've seen, and that way I could add capacity, but I don't think that we've really seen the market demand a request that says dynamically provision a complete cluster.
Gotcha.
Right?
Okay.
We can do that through a GitOps flow, and the same repo that I keep going back to has an example where if I deliver a change in a get, I can have it provision a cluster based on that GitOps flow using all the same resources that I've manipulated through the web UI. But I don't think we've seen dynamically provision a cluster. What we would typically see is I've got another cluster in the pool that matches, and I'm going to take those application components and deploy them over into that cluster that matches. And so I still maintain whatever that minimum replica count is that's declared by my placement rule.
Gotcha. Cool. Thank you.
No worries.